Today's lesson, section 4.3b, I'm talking about logarithmic functions. Example 5 here will be just graphing functions from logs. So if I have f of x is equal to log of x base 3, now to graph that it's a little harder to see how to graph a log, how it is right now. But if we use the property that we learned in the last video, where we can change it to the exponential form, it makes it a lot easier to think about graphing logs and a lot easier to find those values. So let's make f of x y, and let's switch it around so that 3 bumps up that y value to make it 3 to the y power, and then that's going to equal x. So now it makes it a lot easier to graph this, plus if we plug in values for y, then we can find x values and then we can graph. Okay? So this first few I'm going to pick 5 values for y, but any other time that I graph or you graph, you only need 3. So try to, just like when we did our exponential functions, try to find the middle, and then that makes it so you get a good picture without having to do a lot of points at the same time. Okay? So if I plug in 0, -1, -2, 1, and 2 into my function, 3 to the 0 would be 1. Okay? If I plug in 1 to the y value, 3 to the first would be 3. Okay? If I plug in 3 squared, it's a horrible 3, sorry. There you go, 3 squared, that gives me 9. Okay? Now, going the opposite way, 3 to the negative first, that would be 1/3, because it flips my fraction, and then 3 to the negative second would be flipped, and then square that bottom number, makes it 1/9. Okay? So when I graph these, you get 1, 0, and then 3, 1, and then 9 will all the way be out here, 2. There you go. It's about as good as it's going to get. And then 1/3, -1. And then 1/9, -2. So then my graph, okay, looks something like that. Okay. Now here, if let's say we have a base that's in between 0 and 1, it's the same kind of thing. Make f of x y, flip it around into exponential form, so then I have 1/2 to the y power equals x. I'm going to pick the same numbers here. Okay, so then 1/2 to the 0 power is going to be 1. 1/2 to the first power is going to be 1/2, and 1/2 to the second power would be 1/4. Okay. Then 1/2 to the negative first power would equal the flip of that, so it would be 2, and then 1/2 to the negative second power would equal 4. Okay, because you flip and then you square that number of 2. Okay, so then I want to plot those points. So 1, 0, and then 2, comma -1 would be right there, and then 4, comma -2 would be right here, and then 1/2, comma 1, and then 1/4, comma 2. Okay, so then my graph would look something like that. Okay? So that's kind of how we graph those values. Now, sometimes you don't always have it where 0 is the middle, technically, but sometimes you do. But it kind of messes around with stuff if you want to change how things look. Okay? Now, for f of x equals 2 plus a log of x base 5, here, if I'm going to change it to log form or exponential form, this 2 prevents me from doing it right at this moment. So what I first have to do is take the 2 and subtract it to the other side. Okay, so let's say f of x is y. So now you get y minus 2 is equal to log of x base 5. And so now this y minus 2 is all going to be my exponent. And so then I move the 5 up. So that gets me 5 to the y minus 2 power is equal to x. Okay? So here, if you notice, I'm not going to be able to plug in 0 because that gets me straight to negative 2. I want to plug in a value that gets me 0. So what minus 2 equals 0, which would be 2. Okay? And then, like I said previously, I only expect you to graph 3 points on this. So since you're at the middle, pick one value from either side of the number you plugged in. So 2, 1 less would be 1, 1 greater would be 3. Okay, so then we're plugging in those values. So 5 to the 1 minus 2 power gives me 5 to the negative first, which flips that, gives me 1/5. Okay? 5 to the second minus 2 gives me 5 to the 0 power, which is 1. And then 5 to the 3 minus 2 power is going to be 5 to the first, which is 5. Okay? So now I can plot those points. So then So then 5, 3, 1, 2, and then 1/5, 1. Okay. Now, if you were looking at the next step, we want to find the domain and range. But if you remember from those last equations, we never really crossed the y-axis, right? So and just like this one, we don't cross the y-axis. So usually with logarithmic equations, remember how exponential functions, when we graphed them, they had an asymptote of y equals 0. Here we have a vertical asymptote where it's x equals 0 instead. So that kind of prevents your domain this time, instead of your range, from being all the values that it wants to be. So the domain is going to be the one that's restricted. So then if you can't be, for this one, can't be less than 0, it doesn't equal 0, but it can be all numbers to infinity, positive infinity. Okay? Now, because the roles reverse, your range can be whatever values, because those are the values you are plugging in. There are no restrictions there. So then you can say from negative infinity to infinity. Right? So let's do another one. So for letter B, let's make this one h of x equal to y. Now here, notice that you have more than just x over there. And also, notice that there is no base. But remember, that's saying it's common log, so there must be a 10 there. So if I switch that around, so this gets me 10 to the y equals x minus 3. So if I add 3 to both sides, then my function, not 4, should be 10 to the y plus 3 equals x. So I'm still plugging in values for y. Here there's no change in the y value, so I'm going to still plug in 0, negative 1, and 1, like I usually would. But here your x's will change as well. So 10 to the negative 1 power plus 3 should get me 1/10 plus 3, which is going to be 3 1/10. We can just leave it as a mixed number. It's not a big deal. Okay? And then 10 to the 0 plus 3. It gives me 1 plus 3, which is equal to 4. Okay? And then 10 to the first plus 3 would be 10 plus 3. Okay, so it gives me 13. So now when I graph, I need to go all the way out to 13. So here, let us go by 2's. change the scale so I can actually make it there. Okay, so that's good enough. So 3 and 1/10, -1, would be about right there. Okay, and then 4, 0. Okay, and then 13, 1. So then my graph would look kind of like this. Now here your x value shifted, so when you rewrite our domain, instead of being at 0, now because of this +3, we've shifted it over 3, so then that means we also add 3 to our value that it's not going to cross. So if you kept going, let's say you did 10 to the -3rd plus 3, then that would be like 1 over 1,000 plus 3. So you'd have 3 and 1,000th, which is not going to cross 3 anytime soon. So that's why I can safely say that 3 is the number that it's going to be not equal to, because it's going to be all values just greater than. Okay? And then our range is still from -infinity to infinity. Okay? So have fun.